Hello everyone, and welcome to our Chapter 2 study guide. We're going to get started with number 1 through 16. That first section says, give a justification for each conclusion. So we're going to think through our properties, our definitions, our theorems, and we're going to look at what's happening and then decide what to put. So number one, we get started and we see that it's 3 times x plus 1. And it looks like what they're doing is they are going to distribute the 3 to the x and to the 1. They're passing it out. How do you know what to pass it out to? It is going to be to everything in the parentheses. So whenever you see those parentheses, we're going to think that is our distributive property. Distributive property. All right, let's look at what is happening on number 2. It says angle FED is a right angle. It throws a vocabulary word at you. Then it says if then. So if it's a right angle, then it measures 90 degrees. Okay, that is going to be by the definition of a right angle. If it is a right angle, it measures 90 degrees. Okay, so anytime it uses a vocabulary word, it is usually doing that for a reason. So that's going to be by the definition of a right angle. All right, if TR equals MN, then TR plus 7 is equal to MN plus 7. So I'm just looking at what changes. So this statement is TR equals MN, and they're adding 7 to both sides. What is it called when you add the same thing to both sides? That is going to be our addition property of equality. I know that it's equality because these are equal signs. We're adding 7 to both sides of the equation. All right, number 4 says if MN bisects, they use a vocabulary word, so I'm paying attention to it, angle LMK, then the measure of LMN is going to be equal to the measure of NMK. And that is going to be by the definition of bisects. To bisect something means to cut it in half into 2 equal measures. So definition of bisects. Number 5, this one's interesting. If angle 2 is supplementary to angle 1, so 2 is supplementary to 1, and 3 is supplementary to 1, so they're both supplementary to angle 1, then what do we know? We know that 2 and 3 must be congruent. Okay, that is going to be our congruent supplements theorem. Supplements theorem. I could draw you a quick sketch of this up top, number 5. Let me see if I can do that in a different spot. Sorry, guys. So for number 5, our congruent supplements theorem, I'm going to draw you a picture of that. That makes this a little bit easier. Let's say we've got an angle, and it is 100 degrees. What would be supplementary to 100 degrees? That would be 80. You do 180 minus 100. Okay? So if I told you angle A and angle B are supplementary, that would be true because they add up to 180. What if I told you another angle, C, is also supplementary to A? What would it have to measure? It would also have to measure, if it's supplementary to A, it would also have to measure 80 degrees. So what do we know about angle B and angle C? What's left for both of them? 80 degrees. And since their measures are equal, those angles are congruent to each other. So A and B are supplementary, A and C are supplementary. What are B and C to each other? Those are congruent. So that is our congruent supplements theorem. So that's number 5. All right, the next one, number 6, says if Q is congruent to S and S is congruent to P, well, let's look at this. I like to color code. What's our middleman that is congruent to both of those? S. Our transition person is S. S is congruent to both angle Q and angle P. So the transitive property tells me that I can also know that Q is congruent to P because they're both congruent to S. That is going to be our transitive property. Now, is it of transitive? Let me make sure I can spell this. Is it a property of equality or congruence? Is it a POE or a POC? Because I'm using the congruent symbol all the way through, then it's going to be a transitive property of congruence. All right, if angle 4 and angle 5, the measure of angle 4 plus the measure of angle 5 equals 90, then 4 or 5 are complementary. Again, they use a vocabulary word. So that is going to be by the definition of complementary. If 2 angles add up to 90, they are complementary. If 2 angles are complementary, then they add up to 90. Complementary. I'm not sure what happened there. Tari. Okay. All right, number 8. If E is between R and B on a segment, then RE plus EB adds up to RB. I'm going to draw that out real quick. R is somewhere, or E is somewhere in between R and B. Then those two smaller pieces add up to the whole. What is that called? That is a postulate about segments called the segment addition postulate. It says when you add the two smaller pieces of the segment, it adds up to the bigger piece. So RE plus EB equals RB, segment addition postulate. All right, let's look at number 9. If the measure of angle A equals the measure of angle B, then the measure of angle B equals the measure of angle A. They interchanged the left side for the right side. We, in my class, talked about how that's kind of like the single ladies dance, where your hands turn around and switch. And so it's kind of like saying if X equals 3, then 3 is also equal to X. That's what we did in my class for our hand movements. But this is a property of symmetry. This is symmetric. So is it the symmetric property of congruence, or is it the symmetric property of equality? Well, it is going to be of equality because I'm working with an equal sign. So E is for equal sign, equality. Okay, so the left side is equal to the right side, and the right side is also equal to the left side. So sometimes on a test, somebody will write 3 equals X. That's the same thing as writing X equals 3. So I get to give, if I'm just asking to solve for X, I get to give both of those answers full credit. All right, now it says if W is on the interior of TUV. So if I have an angle, I'm going to just draw it out, and it's TUV, and I have W somewhere on the interior, and this says that the measure of TUW, hard angle, plus the measure of the star angle, WUV, is going to be equal to the overall angle. What is that called? Not the segment addition postulate. This is going to be the angle addition postulate. That just says if you add together, so addition, the smaller pieces of the angle, you get the full thing, the full amount. Angle addition postulate. Postulate. Okay? All right, now let's look at this next one. If 3b equals 15, then b is 5. How would you solve for b? What do you do on both sides? We would divide by 3 on both sides, and then it would give me b equals 5. So what is that called? That is our division property of equality. I divided by the same amount on each side to solve for b. All right, if H and S are vertical angles, then you know that the angle S is congruent to angle H. Okay, so if I were to draw that out, if those are vertical angles, then they have to be congruent. What is that called? That is our vertical angles theorem, our VAT, vertical angles theorem. It says if two angles are vertical, then they are congruent to each other. All right, this is from yesterday. If GH and JK are perpendicular, then they form a right angle. Okay, so if we were to draw that out, it would look something like this. They would form a right angle. That is from the definition of perpendicular. To be perpendicular means they cross each other and they form 4 right angles. Definition of perpendicular, if 2 lines cross each other. These 2 segments are forming a right angle wherever they cross. All right, if H is the midpoint, another vocabulary word, then you know that from G to H is going to be congruent to H to K. If you know that H is the midpoint, that means that the segment on the left is congruent to the segment on the right, which also means that the length from G to H is equal to the length from H to K. That is going to be by our definition of midpoint. All right. Number 15 says if T and S are right angles, then they are congruent. Why do we know that they're congruent? Because all right angles are congruent to each other. What makes 2 angles congruent to each other? They have to have the same measure. So any 2 right angles in the world, all of the right angles in the world, are going to be congruent to each other because they all have the same measure. Okay? Number 16 sets something equal to itself. AB looks in the mirror, and who does it see? AB, that's its reflection. So this is going to be our reflexive property of equality, not congruence, because this is an equal sign, not a congruence symbol. So those 2 lengths would be equal. I always tell my students AB looks in the mirror and sees AB. Our reflexive properties where x equals x, and we clapped our hands, or 3 equals 3, and we clapped our hands. For this one, AB equals AB. And then I also gave my students good life advice. If you look in the mirror and see somebody besides yourself, you need to turn around and run. Okay, so that is for 1 through 16. Reflexive property, you should look in the mirror and you should see yourself. Symmetric property is where the left side is equal to the right side and the right side is equal to the left side. You can interchange those on each side. Okay, so those are our properties for 1 through 16.